Why it's so hard to land on the moon? We did it 50 years ago, after all. Why is landing a spacecraft on the moon so difficult? And given that we accomplished this with Apollo in the 1960s and 1970s, why are we having trouble now? In the wake of the lunar lander Odysseus, from intuitive machines toppling over after a gentle landing, this is a pretty interesting question that many people have been asking. It's a good question too. I completely agree that it's absurd that landing on the moon is so difficult, given that we were successful doing so 50 years ago. The fact that the mechanics of landing on the moon haven't altered is the main problem here. In general, the moon remains the same, although it has traveled 80 inches distant from us in the past 50 years. However, our approach, our destination on the moon, our objectives, and our motivations are all completely different. We're having to redo everything because of this, and it feels like NASA is beginning again. It's crucial to remember that lunar landings have never been easy. It was difficult then, and it is still difficult now. Let's begin with the absurd atmosphere of the moon. The 3 parachutes opened, and the spacecraft made a soft landing in the water after the capsule successfully exited the outer atmosphere. For comparison, Apollo 11 splashed down at likely 10 to 15 miles per hour, 16 to 24 kilometers per hour, after re-entering Earth's atmosphere at nearly 24,000 miles per hour. By contrast, intuitive machines had to use only its engines to reduce their spacecraft's speed from 25,000 miles per hour to 6 miles per hour. Additionally, you must bring the fuel with you. Indeed, the moon's gravity is 1/6 that of Earth's, which lessens the drag on the spaceship. But it doesn't really matter at that speed. All you have are engines, and you must slow down. The moon's surface is terrifying. The moon's terrain is likewise chaotic. There aren't any pleasant oceans to splash around in. Rocks, craters, and regolith or lunar dust are the things that end up everywhere. Not to add that the Apollo landing locations, which were in bright sunshine, are a lot different from the lunar South Pole. We believe that the moon's water ice, a significant resource if we choose to live there permanently, is located at the lunar South Pole. For this reason, the region is the focus of the Artemis missions. However, there are craters that are always in shade and might be the coldest spots in the solar system. The sun never rises over the horizon, thus the shadows are long. This makes it more difficult to observe your landing spot, and therefore you have to be very careful about how the solar panels are oriented. What's happening then? We haven't gotten any less intelligent since then. There are some excellent reasons why we struggle now, whereas we used to be able to accomplish it. One significant difference from Apollo is that astronauts are not on board robotic landers to make real-time repairs. For instance, a master alarm was thrown by the guidance computer of the LM lunar module during Apollo 11 as it descended to the moon's surface. Because the rendezvous radar had been left on, the computer was essentially overburdened and unable to concentrate on the tasks required for descent and landing. The computer was unable to interpret the radar updates as well as the descent and landing due to a programming fault. It keeps rebooting and kicking back faults. Although the humans ultimately made the descent, it's quite probable that the landing would have been canceled if the lander had been entirely automated using algorithms and auto-navigation. Even yet, Neil Armstrong used more fuel to steer clear of the crater and land in a location he believed to be safer after the auto-navigation system recognized it as a safe landing spot. The landing might not have happened if it had been a robotic lander with no astronauts on board. It's possible that the lander crashed. It could have tumbled over and landed on the side of a crater. It makes a big difference to have astronauts on board to handle the piloting and fix mistakes in real time. Additionally, there is money. NASA's budget accounted for 4% of the total federal budget at the height of the Apollo program. About $25.8 billion was spent by the US on the Apollo program. The Planetary Society estimates that, after accounting for inflation, that amounts to about $257 billion today. Furthermore, the United States invested $907 million, or almost $10 billion in today's currency, in their robotic lunar program. For IM-1, NASA awarded $118 million to Intuitive Machines, a business with roughly 250 workers. They also spent over $100 million of their own funds. When you have all the funds necessary to complete a moonshot, it's simple. It's far more difficult when you don't. Apollo posed a serious risk. Astronauts literally perished as a result of poor decisions and errors. However, NASA had the funds to conduct numerous tests. Additionally, they had the funds to incorporate redundancies into all of their systems. The LM's ascent engine had been fired in orbit and around the moon, so if it didn't fire on the surface of Apollo 11, that was it. Of course, there were some things that couldn't be tested. Neil Armstrong would have perished on the moon. It should be noted that the ascension engine was made as simple as possible to avoid this. The amount of testing they did on each component was so meticulous and deliberate that it seems unbelievable to think about now. They also had the funds to do it. I simply cannot stress enough how much Apollo's success was due to financial backing and public and governmental support, despite setbacks and hardships. On Gemini 8, a thruster locked in the open position nearly killed Neil Armstrong and Dave Scott as they tested rendezvous and docking procedures. Thus, we made another attempt with Gemini 9 and succeeded in completing the mission. As long as we were attempting to outshine the Russians to the moon, there was a desire for Apollo, which is why the support and funding began to wane when we touched down. Because we wanted to defeat the Soviet Union, people both inside NASA and the wider public were prepared to take on a lot greater risk. It was about overcoming communism, not about science or space travel. We can't do things the way we did in Apollo because of our stricter safety regulations and lower risk tolerance. But that's also why Apollo had so much support, and why we haven't returned to the moon in 55 years after making a few landings. Before Apollo succeeded, it failed numerous times. Before Apollo ever took off, the rocket was on the launch pad for a routine test when it caught fire, killing 3 astronauts. Numerous blunders, human error, failures, miscalculations, and other mishaps were all there. However, we persevered and completed the task. We reached the moon. When it comes to Artemis, NASA's plan to return to the moon's surface, the agency is facing criticism from all sides. Some claim that space exploration is unnecessary. Some argue that the funds ought to be used more locally. It is said to be excessively costly. Those who oppose NASA's collaboration with private firms like SpaceX and Astrobotic and Intuitive Machines frequently say both things in the same sentence, that it's too costly and shouldn't use commercial spaceflight, even though NASA is working with these private companies in part to reduce costs. Yes, NASA handled everything internally during Apollo, and it was quite costly. This time, they're doing several things differently. Additionally, NASA has a lot more bureaucracy now than it had in the 1960s and 1970s, to be honest. That certainly doesn't make things any easier, nor does the fact that we lost a lot of generational information about how we did it since we took so long to get back. We have already experienced the improved technology, but in some respects, we are having to relearn everything. Leave your ideas in the comments section below, and don't forget to like and subscribe for more related content.